Hi, a common problem that students ask me about is limiting reagent calculations. I'm going to work through this problem in which you're asked to calculate the amount of carbon dioxide gas that is produced by 32 grams of methane with 32 grams of oxygen. Now, this is a limiting reagent calculation because the reagents are not present in their stoichiometric proportions. One of them will run out before the other one, and when it does, the reaction stops, thus limiting the amount of carbon dioxide that's produced. We begin by writing out the balanced chemical equation in which methane gas reacts with oxygen gas to produce carbon dioxide and water, which is also a gas at the combustion temperatures. Now, the equation is not balanced at the moment, so can you have a look at it and see if you can put it right? I'll give you a couple of seconds. Good. Did you get it? We've got 4 hydrogens on the left but only 2 on the right, so if we double the amount of water, the hydrogen's good, but now we've got 1, 2, 3, 4 oxygens on the right and only 2 on the left, so we can bring the oxygen up and now we have a balanced equation. To find which reagent is limiting, you need to perform 2 calculations, one for each reagent. So, starting with CH4, we calculate the number of moles of carbon dioxide that we could produce if all of the methane reacted. The strategy we're going to use is to convert the mass of CH4 in grams into, you guessed it, moles of CH4, and then finally into moles of CO2. Let's put some numbers on this. 32 grams of CH4 times a conversion factor, which is going to be 1 mole CH4 divided by 16 grams of CH4, just the molecular weight of CH4, 12 plus 1 plus 1 plus 1 plus 1. And now we want to find out how many moles of CO2 are produced for every mole of methane. Look at the balanced equation, we see that 1 mole of methane will produce just 1 mole of CO2. So we'll put 1 mole CO2 over 1 mole CH4. I'll just tidy up that O there. And that's going to give us, well, we've got 32 divided by 16 is going to be 2 mole CO2. You can perform a quick check by cutting out or cancelling like terms, so that cancels, moles of CH4 cancel, and our result is in moles of CO2, which is precisely what we want. In the second calculation, we work out how much CO2 would be produced if oxygen were limiting. So, the strategy we'll use, as before, is to convert grams of oxygen into moles of oxygen and then convert that into moles of CO2. When we have that result, we can compare the amount of carbon dioxide produced by methane and by oxygen and then find out which was the limiting reagent. To convert the mass of oxygen into moles of oxygen, we have 32 grams, which is what we started with, multiplied by a conversion factor, which is just its molecular weight. 1 mole of O2 has a mass of 32 grams. Now we'll multiply that by the stoichiometric ratio taken from the balanced equation. Here's the equation. We have 2 moles of O2 produces 1 mole of CO2. It's 2 to 1. So 2 mole O2, 1 mole CO2. If you notice, I put moles of O2 at the bottom and here so that units cancel out and our end result will be in units mole CO2. Now looking at this, 32 divided by 32 times a half, the end result is a half mole CO2. We can compare the CO2 produced by CH4 and by O2. Well, for O2 is 0.5 mole, point there, and for CH4 it was 2 mole. So we can see from that oxygen is limiting. So the original question asked for how many grams of carbon dioxide would be produced. We need to convert 0.5 moles of carbon dioxide into grams of carbon dioxide. We write 0.5 moles of CO2 and we have to multiply that by our conversion factor, the molecular weight of carbon dioxide, which is 44 grams per 1 mole of CO2. That comes out to 22 grams CO2, and that is the amount of carbon dioxide produced by 32 grams of oxygen.